Right, I want to demonstrate a couple uses of a spreadsheet for running a hypothesis test. So let's note we are at the end of the course here. We're finishing up Chapter 6 this week in Chapter 8, and then next week is the final review assignment and the final exam. The data I want to look at is related to eating organic foods and pesticides that are present in most of our foods that we eat. The study I want to look at is part of it's here. So here you might recognize these as box plots. So we have some vertical comparative box plots. And these are measurements. Let's focus on, say, this one about the 3 PBA. When people were eating non-organic food, the amount of 3 PBA that was in their system ranged from pretty low down here to pretty high up here. The median is located there. You can see this distance here is our interquartile range. So there's a wide range of this chemical in the bodies of people in this study. And then they switched to organic food, and after eating organic for a couple of weeks, the 3 PBA was measured again, and here we can see this distribution is pretty squashed. Mostly it's pretty close to 0 down here at the bottom with one outlier there. Information. So this was a study from 2015 with a Swedish family that originally ate non-organic food, a conventional diet, and then they measured levels of different pesticides in their systems, pesticides, and then after eating organic for 2 weeks, they then over a week measured again for those pesticides. And I have the original study here. There's a link there. I'll put them in the description of the video if you want to look more into it. And so we're going to look at first a confidence interval and then a hypothesis test for the difference in the 3 PBA amounts. All right, so here is the data from that study. There was a mother, a father, and 3 children. And there were different pesticides that they were testing for. We're going to look at the 3 PBA one, and I've extracted this data into another tab here to get just the numbers I want. So what I want to do is for each person for day 1, 3, 4, and 6. So day 1, non-organic, how much 3 PBA was in their system versus day 1 of organic, how much 3 PBA is in their system. And so this would be the difference of non-organic minus organic. So if the difference is positive, that means there was much more of the 3 BPA in their system when they were eating the non-organic and not much eating the organic. So if we look at the original data set, we can see that. Let's look at the first few here. So father day 1, 3 PBA of a conventional diet was 5.7, and then day 1 of the organic diet was 0.8, 5.5 on day 3 of non-organic, 1.3 on day 3 of organic, and so on. Right, so we're looking at the difference here. All right, so next I want to take that data and put it into a spreadsheet that's ready to do either a confidence interval or hypothesis test. So I'm going to grab the title and the differences there, and then I'm going to go over to that spreadsheet that I had shared with you, and I am doing a single variable, not 2 in this case because I subtracted, and I have now a single column. So I want to let's do a confidence interval for a mean with data first to see what that looks like. So I'm going to get rid of the average mercury data. Just always delete first and then paste in your data. Make sure there's no accidental overlap. Cool. So I'm getting an average difference of about 24. And let's see, what are the units on that? I should say that here somewhere. Micrograms per gram. Okay, so micrograms of 3 PBA per gram of their urine. Okay, got it. And so this is giving me the confidence interval right here. So I'm going to do a 95% confidence interval, so I have to select my confidence level, right? If you're doing a 99% confidence interval, then you would change that to 0.99. But I'm doing 95 one, 0.95. All right, and so this is the margin of error in the interval there. So I'm going to copy this over into my, what do I need? I need, I guess, most of this. Screenshot. So I'm going to draw out what my confidence interval is. That will do. And stick it in my notebook here. All right, so I'm going to sketch the sampling distribution and then state what it means. So my sampling distribution is a bell-shaped curve. Stat key looks funny, but we smooth it out. In the center is whatever my sample mean, and this is a difference in means, and so I'm finding the difference. So we're going to call that x bar is about 24.25, and that was micrograms per gram of 3 PBA, that's a B, believe it or not, in their urine. And I'm finding the lower estimate and the upper estimate for my 95% confidence interval. And so that's going to leave 2.5% in each tail here. And the values that cut off that lower part are about 16, let's go 2 decimal places, 0.68, and the upper is 32.36. So we are 95% confident that the difference of the amount of 3 PBA in their urine switching from non-organic to organic food is somewhere between 16.6 micrograms per gram and 32.36 micrograms per gram. So again, what I'm estimating here is the mean difference and that each value in there came from the non-organic minus the organic. And so since this mean difference is greater than 0, right, 0 is not in that interval, there is always much more in the non-organic urine than in the organic urine of this chemical 3 PBA. So what I want to do next is run a hypothesis test to just kind of confirm that if you eat organic, you will have significantly less of this chemical in your body. So let's switch over to the hypothesis test. So this is telling us the difference on average of organic versus non-organic amounts of 3 PBA is somewhere between 16 and 32. Right, way above 0. All right, so we're going to grab that same data. It should be copied. And I'm going to switch to a hypothesis test. And I don't think I need that data. Let's duplicate the tab. Oh, wait, let's see. I don't want to mess with this particular version. Oh, we'll just undo it after. Ooh. Gosh, that was the last thing I copied, wasn't it? Let's try that again. Copy that. Helps if you copy the right stuff. All right, so I should find I have the same mean, about 24.52. Yeah, looks good, same mean. So I got the data in there correctly, and my null hypothesis is going to be 0. That we should say, hey, what does it matter if you eat organic or not? You're still going to have chemicals in your bloodstream, in your urine. All right, so let's see. What's my hypothesis here? My hypothesis here is that the average difference is going to be greater than 0, meaning there's more of the pesticide in your body when you don't eat organic versus when you do. All right, so let's write that down. Hypothesis. There is more 3-PBA pesticide in humans on average. Got to get average in there. When eating non-organic food versus organic. Okay, so my parameter is the average difference. So this is the population parameter. And it is a mu. That's a shitty mu. Let's try that again. Mu. And mu is going to be the average difference of 3-PBA micrograms per gram in urine from non-organic diet minus organic diet. Right, so the order of subtraction is important. So first I find X for non-organic for each person, and then I find X organic for each person, and I subtract them, and that gives me this X value. That's the difference between them. And then after I get all those differences, then I go and find the average. All right, order of operations is important here. And so just a reminder, that's what I did back here in this spreadsheet. I took the original data, which was the amount of 3-PBA in their urine when they ate non-organic, similar timeline, but after eating organic food, and then I found the difference of those there. All right, back to the spreadsheet. So the spreadsheet gives me my standard error, and it gives me a p-value, and I am going for a right tail test, not a two-tail. So let's make that greater than 0. So that means I'm going to choose the right tail down here. Whoa, that's a small p-value. 0, 0, 0, 0, 0, 1. How many zeros? 5 zeros and then a 1. Pretty small p-value. All right, let's make a sketch of what this looks like. What's my t-score? 6.5-ish. All right. So here's what my distribution looks like. I'll draw in a couple of different ways. First, if I just look at the mean that I got, so with a, oops, off just a little, hypothesis test, we don't center it on the sample, we center it on what the null says, and the null says we should have, on average, no difference. I found, let's think about this for a minute, how many standard deviations to the right? 6.5. Standard errors, almost 4. The t-score here is 6.5. Yeah, way the hell out there. So if you think about the 95% rule, 95% of values are going to be within 2 standard deviations on each side of the mean. Right, so that's in this range here. I'm finding a number of standard errors farther than 2. So 1, 2, 3, 4, 5, 6, 7. So I am finding a t-score of about 6.5, and that goes along with my average from my data, which was a mean difference of 24.5. That was that micrograms per gram of the chemical in the urine. Way the hell out there. The p-value is the amount of other samples that could live out there, and my spreadsheet says my p-value is wicked small, 0.123451. So the probability that I'm going to find another sample that has an average difference of 24.5 or more, right, out this way, when I was expecting there to be no difference between eating organic or not in the amount of pesticide in their urine, the probability is wicked small. Right? What is that? Tenths, hundredths, thousandths, 10,000s, hundreds, thousands. There's a 1 in a million chance of finding another group of people like this. It's pretty unlikely. So that means either I have a weird group of people, or if I think I have a good representative sample of people, then there's something wrong with my null hypothesis and I have to reject the null. So I'm going to assume I have a good data set and I'm going to reject the null hypothesis. All right, that's my decision. My conclusion is that I have sufficient evidence to support this hypothesis right here, that there is more 3-PBA pesticide in humans on average when they eat non-organic food than organic food. That the average difference of 3-BPA micrograms per gram in the urine from non-organic diet minus organic diet is significantly greater than 0. Boom, done. Hypothesis solved. All right. Next, I'm going to compare this to when we can't subtract ahead of time and we have to treat these as two different averages. So this is what's coming up in the last part of chapter 6. So I'm going to jump over to StatKey to grab some data, and I'm going to consider the mindset matters data. And so here I have weight change